Hi, we will have 10 projects in this video. The first one will be turning on and off an LED using Arduino. Then we will use push button. When you press it, the LED will be turned on. Release, it will turn off. After that, we will use toggle. Every time you press the push button, the LED will turn on. With next press, it will turn off. Then we are going to fade the LED by reducing the intensity of light of it. After that, we will fade the LED using push button. Then we will use two LED and create a seesaw project. We will have walking light using LED. Then we will have walking light with push button. With every push, one LED will turn on and the light will move. Then we will use LEDs to measure the voltage from potentiometer, so each LED represents a voltage from 1 to 5 volts. Then the last project is a traffic light, where we will use Arduino to simulate or build a traffic light. Hi, welcome to an Arduino step-by-step course by RoboJax. I have seen a lot of requests and interest, and also realized that learning Arduino would be better with simple programs to control LEDs and also use push button to do different tasks. A series of 10 projects in this video. We're going to learn from simple LED, turn on and off, and then fade, and then use simple push button, and then we will build all the other examples, including the bar voltmeter and LED traffic light. You just need 5 LEDs with 5 resistors. You need one push button. For traffic light, you better to have 3 different colors so you can see it. Otherwise, you can just label them if you want to practice. But for the potentiometer, I'm using also this slide potentiometer and this knob type in both cases, so we will make these lights to read the voltage for us. Light emitting diode, or LED. It's LED, not LED. LED can be different colors. Here is a symbol for LED. We have one line, the line that is, this is the shape of triangle with a line. On the right side, it is cathode, where the line is. On the back of the triangle is anode. This will be connected to positive, and the other side will be connected to negative, so this will turn on. The 2 arrows, there will be some kind of arrows. In this case, 2 arrows shows that this is LED. If we do not have these arrows, then it is just simple diode, not light emitting diode. And we have cathode and anode in actual physical shape will be like this. So pay attention to the one that is like L shape here. That is the negative. The other side is the positive, or anode. We will see LED is used also in lights, even in counters. This is an RGB LED, red, green, blue, which you can create any color. I have separate video and lecture for that. And these are different shapes that you might see in different sizes as LED in different applications. So this is an example of simple LED to be turned on. Let's say you have a 5 volts and you want to turn on an LED. The LED has operating voltage. Usually it's approximately about 2 volts, but you have to look at the data sheet. So we treat it as 2 volts. So this needs 2 volts, and we have a source of 5 volts. So the 3 volts should be dropped on a resistor, so 2 volts will be remain. So we now have the voltage for this, and for each LED, for the small 2 millimeter and 5 millimeters, the current is approximately 10 milliampere. This current is not critical, which means if you have less current, it will be less bright, it will be dimmer. But for optimal current, you have to look at the data sheet and provide exact current so you get maximum brightness and efficiency. So in this case, if we treat this as 10 milliampere and 2 volts, then to calculate R, we use Ohm's law. R is equal V over I, the voltage that is across this resistor, and I, that current that passes. Because this LED needs 10 milliampere, that 10 milliampere will pass through this resistor, through the LED, because this is the only path. So the current for the LED is the same current as the resistor. So V divided by I is current in ampere. So 3 volts, the voltage of a resistor, divided by 10 milliampere. So 10 milliampere can be written as 0.01 ampere. We use here ampere, and we calculated this resistor to be 300 ohm. So with 300 ohm, with this particular LED, we get maximum brightness and very efficient way to bias or turn it on. Because you might not have 300 ohm, so start using 300 ohm up to 1000 ohm will work fine. The higher this resistor value, the less bright the LED. The first project is to turn on and off an LED using Arduino directly. So we will learn how to connect, how to wire, and how to turn it on and off with the different speeds. Here is the wiring diagram. When you insert an LED, I've used FritzZing. FritzZing is a free software that you can get it from fritzing.org. Here, fritzing.org. I will provide you the link so you can download it and search for the parts and drag any part that you want from the right side. Drag any component that you need and just use them. So I have here an LED is connected to the breadboard, where you can get also breadboard and drag it here. And from here, from the right pin, I've connected it to pin 3. From the left pin of this diode, it is connected using this resistor to this line, where I've connected it to ground. So this will just turn on the LED for me, and also it shows the schematic here. Anode of the LED is connected to pin 2. Cathode, where the line is connected to the resistor, where the other side of resistor is connected to ground. And here I've inserted here 1 kilo ohm resistor connected to this pin, and I have this LED. The shorter pin is on this side and the longer pin is on this side, like that. And from this pin, this will go to pin 3. This orange wire is connected to pin 3. From the other side of resistor, it is connected to ground. For the push button, you can use this type of push button. To use your continuity tester, I'm using my multimeter with continuity tester. So if I connect it, it makes buzz. So if you have 4 wires, 4 pins connected to the 2 pin, so these 2 pins cannot be used. So whichever makes buzz, use one, and the other one, the one that doesn't make beside it. So if I come here, this make buzz, I can use this pin. So these 2 pin can be used, the one that doesn't make beep, or these 2 pins. So 2 wires will be connected. If you're using this type of push button, just connect this on the breadboard, or with the wire, connect them between pin 2 and ground. Videos, I've already prepared this push button with these 2 wires. So this is connected to pin 2 and the other side is connected to ground. And here is the code for that. First, we define LED pin, in this case pin 3, as constant of type integer. When we use constant, it means this value cannot change throughout the code, it is constant. And we have on time as constant and integer. For example, in this case 2000 millisecond. So we set it in millisecond, and if you want half second, set it for 500 milliseconds, for example, time off is set. Inside the setup, which is from here to here, it will run only once. We use pin mode, LED pin, which we defined here. This is as if I type here 3. So pin mode, pin 3 as an output, so this line makes pin 3 to work as an output, and this line writes digital write to pin 3, the same pin, low, which means send 0 volt to this pen, so the LED will be turned off. This line initializes the serial monitor with 9600 baud. We upload the code. When I click this, the code will be uploaded to Arduino when it is connected. So I'm going to show you. This will initialize the serial monitor with 9600 baud, and this is printing this text. This is not with push button. On off. So let me upload it again so you see this text. To open the serial monitor, we click on Tools and then Serial Monitor. We can also press Ctrl Shift M, or on the right side click in here. If the board is connected, you will see the result here. It says light on and then light off, light on, light off, and this was the text that was in here, this text. At the bottom, this is 9600. Make sure this is 9600, otherwise you will not be able to read it. Now inside the loop, this portion of the code will run only once and it will stop. But this portion which says loop starts from here to the end. This will run continuously. So first it will run this line, and then line by line it will run it, and I'm going to explain it. We use digital write. This is a function. We say get the LED pin and set it to high. So this will set the LED pin to high. The LED will turn on, and then we use serial.println. ln mean it's the opposite, line new or new line. So this will print this text, and next time it will print it on the next line. So it will just create an enter for us on the screen. And then we have delay on time. So the light is on, and then it will keep it waiting for this long, whatever time you set at the top of the code. And then digital write, the same LED pin. Now we are turning it off, and we print this text and keeping it off for the off time. This was on time, off time, which we defined them at the top of the code. So these three lines is just for turning it on, printing the text and keeping it on, and this is for print the text and turning it off. When it reaches to this point, there is nothing to do. The loop will come back and execute this line, and line by line it will continuously do the same thing. Once your code is ready, connect your Arduino to USB to your computer, then click on this button to upload it to the board. In order for Arduino to work, you just need once to connect and program Arduino. After that, you will disconnect it, power it from battery, from power adapter, or from 5 volts. It will work without computer. Now we are going to use a push button switch. It's simply a switch that when you press it and release, it comes back and disconnects the two wires. You can use this type of push button, or you can use this type of push button which has long pins. Or you can, if you don't have push button, you can use just simple normal switch. Just find the two wires that is turning on and off, so you can turn it on and off, and it will act like a switch for this demonstration if you don't have it. So when you press it, it will turn on and it will stay on, but we can change the time so it can be turned on, and release, it will turn off. Here is the wiring diagram for LED with push button. LED is exactly the same as before. Now we have added push button. Push button has two wires. We have inserted it to breadboard. The right pin is connected using this red wire to pin 2, and the left pin is connected to the ground here. There is a code for the push button. With LED, we define a push button pin, in this case pin 2, and LED pin is the same as before. We have set to pin 3, and delay for LED, how long it will stay on. If you want it to turn off immediately, when you remove your hand, just make it 0. I'm going to demonstrate that. Inside the setup, we use pin mode, and we use the push button as input pull-up. When we use input pull-up, it pulls up the pin when you don't press it. So if you don't use the pull-up, if you use like this, then you will need extra resistor on the push button, which I have separate video. The link will be below the video, or check it so you can see that. Otherwise, you use this and it will pull up the pin when you don't press it. When you press it, it will go low. So this is for push button. And then using pin mode, LED pin, we define it as output. This is the same as before. initializing the serial monitor. This is just printing the text. And inside the loop, we use digital read push button pen. So this is reading the push button, and the result, whatever it is either 1 or 0. When it is pressed, it is 0. When it is not pressed, it is 1 or high. So here we check if this highlighted area, digital read the function with this pen, if it is equal, these two equal mean compare it with a value of low. Low means 0. I could type also 0, but low makes sense. This is a defined constant variable from Arduino internal code, so I've used it. So we check it if it is equal low. If this line, the condition is equal true, then we say button is pressed, then we say digital write LED pen high. So this will turn on the LED or sends 5 volts to this pen, which is pen 2 and pen 3, sorry, and then we print this text LED on, and then we keep it waiting for this LED delay time that we set at the top of the code, so the LED stays on. When you release your finger, and if this is not true, then we say digital write LED pen low, because if it is on, we have to turn it off. So this will turn off the LED pen, and the code will continue to do the same thing over and over again. And now here is a demonstration. At the moment it is 1 second. Let me upload the code. It is 1000 milliseconds or 1 second. Wait for this to complete. As you can see, when it is done, now if I press this, the LED is on, and it will turn off until the time ends that we set here. If I set this to 5000 milliseconds or 5 seconds, here now it's 5 seconds. You see, it waits for 5 seconds before going turn off. If you want this to turn off immediately, just set it to 0. It's 0, so when I press my finger, it's on, release, off. So going to turn on and off the LED using this push button, but this is different. This is toggling it. So when you press it, the LED is on. When you release it, it stays on, and when you press it next time, it will off. So this is a push button to turn on and off. One push on, one push off. And here is the code. We define a push button pen. This is exactly the same. So we have these 3 variables. These are changing with the code. Inside the setup, this is exactly the same, and here we read the push button pen. The result, whatever it is stored in this variable called push button status, and this is printing the status, just extra, just removed it. Here we checked if push button status is equal high, which means the push button is not pressed, and the light status is low. In that case, it says if this is high and the light status that we set, light status here 0. If it is low, then we set pushed 1 minus pushed. This is toggling it. There are so many ways to do it. I prefer this one, so let me explain it. If it is 0, let's see, 1 minus 0 is 1. So this was 0. Now the result of this calculation, which is 1, will be stored here. If this pushed is 1, then here 1 minus 1 will be 0. So 0 will be stored here, and we have 100 milliseconds for the finger to be removed. So we are just changing the push, and then we are setting the light status, whatever is a push button. We say light status equal this, high or low. And here we check. We check if push is equal high, so that status that we had. If it is supposed to be on, then we print this text on the screen, and then we turn the LED pen high, so the LED is on. Else, it means this is not true, so it is low. Then we send the signal low to LED pen to turn the LED off, and also we print this text. And the loop continue, does the same thing over and over again. Here's the demonstration. Turn on, turn off, on, off. And this is very useful in many applications. The example that I've given here for push button and LED, this is not about LED. This is about a lot of other applications. You can connect this to a relay to turn on and off an AC light, to control a motor, and do so many other things with push buttons that toggles. We are going to work on fade. Click on File, Example. This is built-in Arduino code. Go to Basic and Fade. I'm setting the pin number 3 for LED, and this is brightness, a value 0, fade amount, every step how much it should fade, because the Arduino will go with up to maximum of 255, so it's 2 to the power 8 bits. And inside the setup, we set the LED pin as output, and this line, digital write, LED pin with the brightness. The brightness will be like 0, and here we change the brightness. In this line, we get the brightness and we add fade amount, which is 5 at the top of the code. So brightness 0 plus 5, now it will be 5, and next time when the loop comes it will be 10, 12, and so forth, so up to 255. This line is taking care of it. If brightness is smaller than 0, it doesn't allow it to go below 0 or negative or above 255. So here what it does, if it is below 0 or if it is greater than 255, then fade minus fade. So what it does is it changes the value of fade amount, which was 5, it makes it negative 5. If it was negative 5, if you put in front of it negative, it will become positive. So this amount either increase or decrease depending at which edge it reaches. So, and we have 30 milliseconds to take the effect, and it will continue. So this line will receive the brightness based on these conditions. It will change, and this will update it. Let me upload the code. So it is fading. So it is fading and turning on and off, and amount of fade depends on the steps that you set. So it can be very quick or it could be very slow. Here, if this was 5, let's say if you set it to 20, it will be fading out and in very quickly. So now this is fading very quickly. Set it to 3. So it's taking much longer. Now this project will fade the LED with a trigger from push button switch. If I just trigger it, it will turn on and it will fade out. Here is the code. We use the same push button pin, pin 2, LED pin 3, and here we have fade amount 20, or how fast you want from between 0 to 255 to make the LED fade, and the fade speed. This is the time in millisecond, and that is the step of fade. So fade amount and fade speed are two different things. So you can do this fast with so many steps. Because from 20 to 255 will be certain steps, but it will be slow or fast if you want. If you want to make it slow, just change this number, and these are the values that are used inside the code: brightness, maximum initial brightness, or how bright, to 255. Push button status is holding the push button value. These are exactly the same as main push button code. Here we set the brightness at 255, and then push button, we read the push button status, stores it here, store it here, and then we check if push button is equal low. If it is pressed, then we check here using while. While is a loop. I've explained it fully. You can see multiple examples of that from the link below. But here, as long as this is greater than 0, this portion, which is start from here to here, will continuously be executed. So we first wait 100 milliseconds, and then analog write. We write to LED pen the amount of brightness, initially 255 when it is pressed, and then we get the brightness and slowly fade it by the amount of fade, whatever amount we have. And then the delay, we have fade speed, so 5 milliseconds, it will wait 5 milliseconds, and here we check if brightness is smaller than 0, which is negative, we set it back to 0. Now we don't care about 255 because while loop will exit. If the button is not pressed, we send the value of 0 to LED pen using analog write. So when the loop finishes, comes back, again brightness will be set to 255, so it will start from maximum brightness to 0. And here is a demonstration. I'm going to change the value so you can see it. Initially we have this at 20, so let's fade it in terms of step. So the code is being uploaded. If I press this, you see it's taking a lot longer to reach to 0. But if I go 50, now wait for this code to be uploaded, so it will be in 5 steps. Now let's see. Now I can do this like 10. Code is uploaded. Now it takes longer, but let's reduce the delay to 1, which means 1 millisecond. It will be very quick. Now pay attention. It took a lot longer. This is the project Seesaw. We will use 2 LEDs here, in this case red and green, and they will turn on and off after each other. They look like seesaw. Here is the wiring diagram for the Seesaw. We have a breadboard. 2 LEDs have been inserted at this point. From the left pin, as you see, from the one that is bent, on this side that is flat, that is a negative. It has been connected using a resistor to this point, and the other one as well, from resistor 330 ohm to this line. This line is negative, has been connected to ground. And from pin 2 we have one wire, gray wire, is connected to anode, and from pin 3 we have connected another wire to anode, so the LED will be turned on. And here is, if you need a schematic diagram, LEDs, resistors in series. Here is the code for Seesaw. First we define a green LED pin number 2 and red LED pin number 3. The on time, this is the time that each LED will be on. So then inside the setup, which runs only once, from here to here, we use pen mode to define pen green LED pen as output, and also use the same pen mode again for the red LED pen as an output. So these two will be defined, 2 pins will be defined as an output, and the serial monitor is defined here, and this will just printing the text. In this line we see digital write, green LED pen high, so this will turn on an LED, this will print the text for us, and this will keep it on whatever set we have, whatever time we have in this on time. So 500 milliseconds, for example, we set, and then after that we turn it off, green LED low, so this line will turn it off. These lines are all just for green LED, and then we have repeated of the same code for red LED. With high, we turn on the pen, LED is on, print this text, and then keep it waiting for this on time, and then red LED low. This will turn off, and this is the end of the loop, and it will come back and turn on the green and then turn it off, and then red on and then red off. And here is a demonstration. The code is running. As you can see, red and green LEDs are turning on and off. Let's change the time to 200 milliseconds so they can turn on and off quickly. Code is uploaded now. It will be very quick. Let's turn it on for 1000 and 1000, which means 1 second. Uploaded. Now this is 1 second on, 1 second off. Now this is called walking light, so the lights are walking. We have used 5 LEDs with 5 resistors. The principle is exactly the same as before. Instead of 1 LED, we have 5, and 5 resistors, 5 wires have been connected. For all of this, I've connected one common. And here is the wiring diagram. I've placed all these LEDs. From the left, we have resistor, but from the resistor is connected to this blue wire. This breadboard has red here and blue, so the top is all connected, this line. So I've connected them in here, all of them, so they are connected to the same wire which is connected to ground. First LED is connected using green wire to pin 3. In this case, I've changed it in case if I need push button, so pin 2 and then pin 3, next one pin 4, 5 and 6. So we have 5 LEDs, and here is schematic diagram. D1, D2, D3, 4, 5 are connected to anode, and cathode of the LED is connected to the resistors, which all of them are connected to ground. And here is the wiring for the walking light. Anode are connected on this side, on the left side, so it is connected to this pin. The second one is also connected like that, so the third and fourth. So there is nothing else on this line except this wire, and the right side, which is cathode, connected to this resistor. This is 1 kilo ohm up to this point, and from here all of these resistors are connected to the same line. This blue is all connected, and from here it goes to the ground. And these pins are, as you can see, they're going pin 3, 4, 5, 6, 7. And here is your homework. Try to set this so it goes and comes back. It is doable if you follow the instructions from my previous lectures. It is very easy. And here is the code. We have defined a LED1 variable of type integer as constant. I have set it to pin 3, and for 2, 3, 4 and 5. Accordingly, I pin pins so we do not make mistake. Here we set off time, for example, how long it should wait. Off time 1 second and on time 3 seconds, 300 milliseconds. And inside the loop, inside the setup, we set all these LEDs, LED 1, 2, 5, as output, so they act as an output. And inside the loop, this is for one LED, and for each we have the same amount. I could make it fancy by using advanced code, but because this is introduction, we have to go and very slowly so the student can understand. Digital write LED 1 as high, so this line is turning LED 1 pin as high, so the LED is turned on, and then we keep it waiting with the delay of on time, which we defined at the top of the code. After that, we turn it off using digital write LED 1 as low, so this was turning it on, this was turning it off. So this was sending 5 volts. If your Arduino is 5 volts, it will send 3.3 volts if your Arduino is 3.3 volts like Nano or other versions, and then low will turn it off and then keep it waiting. After that, it will be turn off the second LED the same way. Turn on, wait, turn off, and then wait. And then LED 3, the same thing. LED 4, the same thing. LED 5 the same thing, end of the loop, and it will come back and repeat the same thing over and over again. The current code, this is the speed. As you can see, they're walking. If you want to, so the off time is that the time between one to the other one. If you want this to go very quickly, you can go and set it quickly. For example, let's set the off time to 200 and on time to 200 and upload the code. And now it will walk like that. As you can see, the on time and off time looks like that. But if I make this 50, if I make this on time 50 and off time longer, so it will look like that. Now let's do the opposite. Off time shorter, on time longer. Let's see. And if I make this very fast, so on time shorter, and then off time also 30, so it will be very quick. Let's see. Off time 30, it will be very quick, and on time also shorter. Let's see. So this is now this project. Now we are advancing the LED by push button. So if I press it, the first one is on, and then we are moving the light with push button. It goes to the next one, and next one. So it just rotates like that. The wiring is exactly the same as walking light, and the push button is located at the exact location. Now here I've connected to pin 8. The push button, the left is connected to this ground, which is connected using this wire, and the right pin is connected to pin 8. Of course, you can define any other pin, but it's just an example. And here is a schematic. This portion is exactly the same as the walking light, but in this case from pin 8, we have this push button switch which turns on and off. One side is connected to pin 8, the other side is connected to ground via this wire. Now let me explain the code for the walking light with push button. First we define again push button at pin 2, and these are the same as before. All those pins have been defined for LED 1 to LED 5. Here we have a variable called LED on. So initially we set LED 1 to be on when push button is pressed. And this is a push button status. Initially we set it to false. It's used inside the code. Don't worry about it. So we're so this is, we are initializing a LED pin, and then we are setting all 5 pins as an output. So we have seen all of this code. The important part is in here. So we read the status of the pin, and we store it in a variable called switch pushed, and we check if switch pushed is equal low, which means it has been pressed. Then we take all this action from there to here. So everything that happens inside the loop is only happening when you press the button. First we toggle it, push button state 1 minus push button state, as I explained it in the toggle example a few minutes before. Check that, and then we print this. So this is printing the text on the serial monitor. We are waiting 200 milliseconds, giving the user to press the button. And here we check if LED 1 is on. Initially it is on. Then we set for the next LED 2. So this is for the next one. And here we set all the pins low except LED 1 high, so this will turn on LED 1. And if LED 2 if it is equal LED on, then the next LED will be LED 3, and here we set LED 2, whatever it is, as high and the rest low. So one LED is on at the same time. The same way for 3, LED 3 is on, and then LED 4 is on. Else means it is LED 5, so then we set next LED on as LED 1, so it will rotate back, and here we set the last one as high. And that is the loop. This was the if condition. And here is a demonstration. Again, so I'm pressing it. The first one is on, release, next, 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 next. When I press it again, it will come back. And there is 100 milliseconds because if you try to do it very quickly, it might not react. As you can see, it is reacting. So keep in mind that if your finger is shaking or something, increase the time. This time here. So increase it so it allows the user to push the push button. This time here. So increase it so it allows the user to push the push button. But if you increase it so much, you might not be able to even turn this on. Let me set this to 50 and you will see that it will not function properly, and we'll go to the next one very quickly. So now you see when I press it, it went to 3 because I have to do it very quickly. Now I could do it because I'm doing it like too fast, but if you hold it, it will go exactly like walking light project. So with the 200, let's go back. And now again it's 200, but if I hold it every 200 milliseconds, the lights are walking. So you can toggle or hold to do something with this. Now this is now voltage LED bar, and because the Arduino is 5 volts, or you can use 3.3 volts, so we are using 5 LEDs to represent 5 volts, and it goes around 1, 2, 3, 4 and 5 volts. They will be turned on, but in order to check and get the voltage, I'm using variable resistor here, and when I rotate it, as you can see, it goes high and high and high. So that is the maximum that we reached, and I can go back to reduce the voltage and read it. So let's see. There is a wiring diagram. This portion is exactly the same. I've added this variable resistor or potentiometer. The left pin I've connected to ground. The right pin I've connected it to 5 volts. You can connect it also to 3.3 volts to read or measure 3.3 volts if you want it. I've connected to 5 because these are 5 volts, so it will make sense in terms of calculation. And the middle pin is connected to analog 0, where we read the voltage. This is very important that you connect the middle to the analog 0. And here is the schematic. This portion is the same. I've connected this variable resistor, which has 3 pins. The right pin is connected to 5 volts. The left pin is connected to ground, and the middle pin is connected to analog 0. Now let me explain the code for the LED voltage bar. So we set the pot pin or potentiometer pin as analog 0. The rest of the pins are exactly the same as a walking LED. This is exactly the same. This is a show voltage. If it will display the voltages on the serial monitor. Board voltage, if your Arduino is 3.3 volts, set it to 3.3 volts. For example, for Arduino Nano and Mega, it is 5 volts, but there are other boards like Nano 3.3 volts, so you must set it to that value, so you can read proper value. Or top, this is just printing the information and setting up the serial monitor with these text. And then we have these all 5 LED pins as an output, which was exactly the same as the previous project. We are reading analog 0 pin using analog read. The value of this is between 0 to 1023. It will be stored in a variable called sensor value, and then we get sensor value multiplied by board voltage, which is 5 volt, divided by 1023. 1023 is 2 to the power 10. That's a 10-bit analog value for this board. It can change depending on the type of the board. Here on the official Arduino website, for Uno it is 5 volts, for Mini 5 volts, and you can see 5 volts, and then for Zero 3.3, Dewey 3.3, and these are the pins that are available. And here 10 bits, these are 10, and then we have 12 bits where you can set the value. When it is 12-bit, you have to set it 2 to the power 12, wherever your calculator says. Once you multiply the sensor value by this, you will get the voltage. The result of this is voltage, which will be stored in here. And here, if we set show voltage to true, we print it on the serial monitor. This is not important. And then we have 50 milliseconds delay for the analog to read. Here, the first one, we check if the voltage of the is greater than voltage of the board times 0.95. It means get 95% of the voltage. If the voltage is greater or equal 95%, then turn the LED 1, LED 2, 3, 4, and 5 on, all of them on. Now the next stage, if the voltage is greater than 80%, then only the 5 will be off, so it is 4 volts, 4 LED will be on. The next one, if the voltage is greater than 60%, then only 3 will be on, so that is 1 volt, 2 volts, 3 volts, so it will show 3 volts, and 4 and 5 is off. If it is greater than 40%, then only show 2 LEDs, and if it is greater than 20%, it's 1 volt, show 1 LED on. Else, turn all of them off if the voltage is not within those ranges. So this is as simple as that. Now, as you can see, we are reading 0 volts, so just pay attention to this screen, and also I'm going to rotate it slowly. As I rotate this slowly, the voltage will increase, and pay attention to the LED as well. So when it is 1 volt, you are reading 1 LED is on. Let's go for 2. I'm rotating it until it's 2. The second one is on. So 2.07. So that's very accurate so far. Three. So we are reading 3.07. 4, so that is 416, and 5, this is 479. So that's our setting. And also these resistors are 10% with 10% tolerance, so they are 10%, they have 10% error. So you can get better resistors like these blue one. These are metal film resistors. These have 1% tolerance. Slower, so that's very nice. So we can see that it's responding very well. Now if I remove the potentiometer, now let's see what happens. It will randomly turn on and off. So whenever, now let's connect this one. Sliding variable resistor. This looks very nice. Now we are going to learn how to build a traffic light. This is a very simple traffic light. As you can see, the green will turn on, and then we have orange or yellow for a few seconds, and then it goes to red, which lasts longer. So first we have to understand the timing. This is just an example. When the, let's say 3 seconds, it turns on for 3 seconds. So these are each 1 second. This is just an example. After this, for 1 second, the yellow, in some countries it might be orange, so between orange and yellow, so it will be for 1 second on. Then when the yellow is turned off, then the red will turn on. This will last for 3 seconds, and as soon as the red turns off, the green will turn on. So the lower section is off, and then this is on. These solid color are on. The 3 seconds is just an example. We can set in the code whatever period that you want this to be on, it will be on and then off. Here's a wiring diagram for the traffic light. We have 3 LEDs. The LEDs are exactly wired the same as single LED and blink and everything else that we just said. We have connected first LED, the red LED to pin 2, the orange or yellow LED to pin 3, the green to pin 4. From the cathode, from all of them, we have resistor connected to this line. This is also connected to the same line because this line is all connected. And from here I have a wire to ground. And here, if you want to see the schematic, pin 2 goes to an LED to the anode, and cathode goes to resistor, pin 3, pin 4. This is red, green, blue, or green, red, blue, whichever order you want to put them. But make sure to put in the code whatever pin you connect that LED, and all of the resistors are connected to ground. I have connected this wire. This goes to pin 2. This wire goes to pin 3. This wire goes to pin 4. And from here, we have resistor connected. This resistor can be here or can be after that from the other pin. You can put the resistor in here as well. So you just put your wire like this and remove this resistor and put it between this pin and here, where this goes to ground, because this line is all connected, this blue. And here is the code for the simple traffic light. First we define a green LED pin, yellow LED pin, and red LED pin. I've used pin 4, 3, and 2, and these are all typed integer, and we set them as constant so the code cannot change them. And then for the same 3 LEDs, we have set green on time, for example 5000 milliseconds or 5 seconds. We are going to change it and play with this. Red, and then yellow. Yellow is 1 second or 1000 milliseconds, and green and red are the same amount of time, but you can play and change it. Inside the code, we are just initializing the serial monitor, printing this text, and then for red LED pin, green, and yellow, we are setting them as output using pin mode. So this makes those 3 pins as output. Inside the loop, we use digital write, green LED pin high, so this will turn on the LED and this will print the text. This will keep it waiting for the amount of time that we set for the green light. And this line is printing green off, \T mean tab. So it prints this, and with a space below it, because we have LN, a little further, 1 tab to the right after this, it will be printed, and then digital write, green LED pin low, this will turn it off. So this section is just for green. We have exact same thing for yellow LED high, and then we have now 2 tabs will print this. It says yellow LED on, and then keeps it for the amount of time for yellow that you set, and then it prints off and then turns off the LED. And then the same way for red high, this will turn on, this will print it with after 4 tabs, and then keeps it waiting for that amount of time that you set, and then prints this as off, and then turns off the LED. Now I've connected Arduino. Make sure the port is correct. If I open the serial monitor, you will see that it will print it like this: green LED on, and after the time passes, it green off, and then yellow on, and then yellow off, and then red on. Red off, and immediately green on. So this is all one period. Until you see green, this is inside the loop. It happens, and again it starts from here. The new loop starts. Green off, and then yellow, yellow off, red on, and then red off after the time, and green on. Now as you can see, green is on. After that, for a small amount of time, orange, and then red is on. Now let's change the timing. Let's say make it 3 seconds. 3 seconds, and keep this 1 second, or maybe let's make it 700 milliseconds. And once the code is uploaded, you will see it now 3 seconds, and then orange 1 second, and then red. It goes back 3 seconds, 1 second, and then 3 seconds. Let me disconnect it and connect my battery. I'm using these lithium-ion batteries to power this Arduino. Now I've set the timing for green 10 seconds, red 10 seconds, and yellow 3 seconds, 3000 milliseconds. Let's upload the code. Let me connect my battery again, and this will start for 10 seconds. I'm putting the timer. Three seconds, and then again 10 seconds. And it goes back, and the loop continues like this. Thank you for watching the tutorial from RoboJax. If you learned something and found this useful, please thumb up. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this video, I'm going to show you how to use 2 or more, maybe up to 10 push buttons can be used with one analog input of Arduino, so you can save the pins. With 10 push buttons, so we can press between 1 to 10 and detect it. So these push buttons can be used to control relay, load, LED, or whatever you want to control with. To control output such as relay, this time I've connected an AC bulb. You can do with something else. So when I press it, the light turns on, and when I release it, it turns off. Or you can set the output to toggle mode. When you press the push button, the light is on, and you release your finger and press it again, it will turn off. And the same way, all the 10 can be controlled with just one wire. And using it with